Video we mentioned two properties of Java language, security and portability, and we want to explain them in detail in this video. Please subscribe my channel if you like the concept. Okay. The titles in this video are Security, Portability, Java's Magic, JVR, Timing, Performance, and JDK9. Servlet, moving behind the applets, deprecated term, Java Web Start, a faster release schedule, future release, the Java buzzwords. Let's start with the concept of security. As desirable as dynamic network programs are, they present serious problems in the areas of security and portability. Obviously, a program that downloads and executes on the client computer must be prevented from doing harm. It must also be able to run in a variety of different environments and under different operating systems. As you will see, Java addressed these problems in an effective and elegant way. Let's look a bit more closely at each, beginning with security. As you are likely aware, every time that you download a program, you are taking a risk because the code you are downloading might contain a virus, Trojan horse, or other harmful code. At the core of the problem is the fact that malicious code can cause damage because it has gained unauthorized access to system resources. For example, a virus program might gather private information such as credit card number, bank account balances, and passwords by searching the contents of your computer's local file system. In order for Java to enable programs to be safely downloaded and executed on the client computer, it was necessary to prevent them from launching such an attack. Java achieved this protection by enabling you to confine an application to the Java execution environment and prevent it from accessing other parts of the computer. You will see how this is accomplished shortly. The ability to download an application with a high level of confidence that no harm will be done contributed significantly to Java's early successes. Okay, and the next concept is portability. Portability is a major aspect of the internet because there are many different types of computers and operating systems connected to it. If a Java program were to be run on virtually any computer connected to the internet, there needed to be some way to enable that program to execute on different types of systems. In other words, a mechanism that allows the same application to be downloaded and executed by a wide variety of CPUs, operating systems, and browsers is required. It is not practical to have different versions of the same application for different computers. The same application code must work in all computers. Therefore, some means of generating portable code was needed. As you will soon see, the same mechanism that helps ensure security also helps create portability. Let's learn something about Java's magic, the bytecode. The key that allowed Java to address both the security and the portability problems just described is that the output of a Java compiler is not executable code. Rather, it is bytecode. Bytecode is a highly optimized set of instructions designed to be executed by what is called the Java Virtual Machine, or JVM. Which is part of the Java Runtime Environment, or JRE. In a sense, the original JVM was designed as an interpreter for bytecode, and this may come as a bit of a surprise because many modern languages are designed to be compiled into CPU-specific executable code due to performance concerns. However, the fact that a Java program is executed by the JVM helps solve the major problems associated with the web-based programs. Here is why. Let's learn about JVR. Translating a Java program into bytecode makes it much easier to run a program in a wide variety of environments because only the JRE, which includes the JVM, needs to be implemented for each platform. Once a JRE exists for a given system, any Java program can run on it. Remember, although the details of the JRE will differ from platform to platform, all JREs understand the same Java bytecode. If a Java program were compiled to native code, then different versions of the same program would have to exist for each type of CPU connected to the internet. This is, of course, not a feasible solution. Thus, the execution of bytecode by the JVM is the easiest way to create truly portable programs. So, this feature could satisfy the portability. But about security, the fact that a Java program is executed by the JVM also helps to make it secure. Because the JVM is in control, it manages program execution. Thus, it is possible for the JVM to create a restricted execution environment called the sandbox that contains the program preventing unrestricted access to the machine. Safety is also enhanced by certain restrictions that exist in the Java language. So the security is satisfied too. But about timing. And when a program is interpreted, it generally runs slower than the same program would run if compiled to executable code. However, with Java, the differential between the two is not so great because bytecode has been highly optimized. The use of bytecode enables the JVM to execute programs much faster than you might expect. So the problem of timing is solved too. About performance. Although Java was designed as an interpreted language, there is nothing about Java that prevents on-the-fly compilation of bytecode into native code in order to boost performance. For this reason, the Hotspot JVM was introduced not long after Java's initial release. Hotspot includes a just-in-time or a JIT compiler for bytecode. When a JIT compiler is part of the JVM, selected portions of bytecode are compiled into executable code in real time on a piece-by-piece demand basis. That is, a JIT compiler compiles code as it is needed during execution. Furthermore, not all sequences of bytecode are compiled, only those that will benefit from compilation. The remaining code is simply interpreted. However, the just-in-time approach still yields a significant performance boost. Even when dynamic compilation is applied to bytecode, the portability and safety features still apply because the JVM is still in charge of the execution environment. Let's say something about JVCon 9. Of course, After this limited explanation, we will come back to the concept soon. JDK9. Beginning with JDK9, some Java environments will also support an ahead-of-time compiler that can be used to compile bytecode into native code prior to execution by the JVM, rather than on the fly. Ahead-of-time compilation is a specialized feature, and it does not replace Java's traditional approach just described. Because of the highly sophisticated nature of ahead-of-time compilation, it is not something that you will use when learning Java, and it is not discussed further in our explanation. We will come back to JDK9 concept soon. But let's talk about servlet. If you have a question like that, I have heard about a special type of Java program called the servlet. Okay, what is it? The answer would be something like this. A Java servlet is a small program that executes on a server. Servlets dynamically extend the functionality of a web server. It is helpful to understand that as useful as client-side applications can be, they are just one half of the client-server equation. Not long after the initial release of Java, it became obvious that Java would also be useful on the server side. The result was the servlet. Thus, with the advent of the servlet, Java spanned both sides of the client-server connection. Although the topic of servlet and server-side programming in general is beyond the scope of this beginner's guide, they are something that you will likely find of interest as you advance in Java programming. Now, let's talk about moving beyond applets. At the time of the it has been more than 2 decades since Java's original release. Over those years, many changes have taken place. At the time of Java's creation, the internet was a new and exciting innovation. Web browsers were undergoing a rapid development and refinement. The modern form of the smartphone had not yet been invented, and near ubiquitous use of computers was still a few years off. As you would expect, Java has also changed, and so too has the way that Java is used. Perhaps nothing illustrates the ongoing evolution of Java better than the applet. As explained previously, in the early years of Java, applets were a crucial part of Java programming. They not only added excitement to a web page, they were a highly visible part of Java, which added to its charisma. However, applets rely on a Java browser plugin. Thus, for an applet to work, it must be supported by the browser. Recently, support for the Java browser plugin has been waning. Simply put, without browser support, applets are not viable. Because of this, beginning with JDK9, the phase out of applets was begun, with support for applets being deprecated. Okay, let's know what is the deprecated term meaning. In the language of Java, deprecated means that a feature is still available but flagged as obsolete. Thus, a deprecated feature should not be used for new code. The phase-out became complete with the release of JDK 11 because support for applets was removed. Let's know something about Java Web Start. As a point of interest, a few years after Java's creation, an alternative to applets was added called Java Web Start. It enabled an application to be dynamically downloaded from a web page. It was a deployment mechanism that was especially useful for larger Java applications that were not appropriate for applets. The difference between an applet and a web start application is that a web start application runs on its own, not inside the browser. Thus, it looks much like a normal application. It does, however, require that a standalone JRE that supports WebStar is available on the host system. Beginning with JDK 11, support for Java WebStart has been removed. Given that neither applets nor Java WebStart are viable options for modern versions of Java, you might wonder that a mechanism should be used to deploy a Java application. One part of the answer is to use the glink tool added by JDK 9. It can create a complete runtime image that includes all necessary support for your program, including the JRE. As you might guess, deployment is a rather advanced topic that is outside the scope of our discussion. Fortunately, you won't need to worry about deployment to use your knowledge, because all of the sample programs run directly on your computer. They are not deployed over the internet. Let's talk about the next title, a faster release schedule. Another major change has recently occurred in Java, but it does not involve changes to the language or the runtime environment. Rather, it relates to the way that Java releases are scheduled. In the past, major Java releases were typically separated by 2 or more years. However, subsequent to the release of JDK 9, the time between major Java releases has been decreased. Today, it is anticipated that a major release will occur on a strict time-based schedule, with the expected time between major releases being just 6 months. Okay, feature release. Each major release, now called a feature release, will include those features ready at the time of the release. This increased release cadence enables new features and enhancements to be available to Java programmers in a timely fashion. Furthermore, it allows Java to respond quickly to the demands of an ever-changing programming environment. Simply put, the faster release schedule promises to be a very positive positive development for Java programmers. Okay. I think it's enough. Let's talk about the Java buzzwords. Actually, you can see the concepts and their definition in the box is available in the presentation file. So I think that the topic of today is over. Have a nice time.